Okay, so here for you is another example of a function in two variables. I want to describe it geometrically again, as we've been doing, and then I want to find its domain. So remember geometrically, if I ask you to graph something geometrically, to think about it geometrically, what I mean is I'm assuming my heights are given by this function, right? So every point on this function, every point on the graph of this function is going to be x, y, square root of 1 minus x squared minus y squared. These are points on my graph, right? And so let's look at what this looks like. Well, okay, so actually, I mean, let's try to simplify a little bit. If z is the square root of 1 minus x squared minus y squared, then that means that z squared is equal to 1 minus x squared minus y squared. Now we have to be a little bit careful because we've lost some information here. In this expression that I've just written down, z is allowed to be negative. But remember, if I started with z being the square root of something, z should be positive. So this is the function that I'm looking at. Z squared equals 1 minus x squared minus y squared, z greater than or equal to 0. If we rearrange things a little bit, this is x squared plus y squared plus z squared equals 1. And this should start to look familiar. Remember, the equation of a circle in 2 dimensions is x squared plus y squared equals r squared for some r. This is a circle centered at the origin with radius r. A sphere centered at 1, or rather centered at 0, 0, 0 in 3 space, with radius 1 has the equation x squared plus y squared equals z squared, x squared plus y squared plus z squared equals 1. And so, so this is a sphere centered at the origin. Of course, I've left out again this point, so I need to make sure that z is greater than or equal to 0. And so it's not quite a sphere. It's the upper hemisphere of a sphere. So it's going to look something like this, maybe. I'll post all of these on GeoGebra too, so you can see much better pictures than what I'm drawing. It really takes a lot of practice in multivariable calculus to get a sense for how to draw these things. I'm out of practice. So my graphs, and especially on the surface, are going to be a little bit, maybe it may be better to look at a graphing utility and graph this thing. So I encourage you to go into GeoGebra, do it yourself, or I'll post links in the descriptions of the videos if I remember to. If I don't, just remind me. Okay, so geometrically, this is an upper hemisphere. We've answered that question. And the other question was, what is its domain? So remember, domain is the set of all allowed inputs. And now that we're talking about three-dimensional functions, now we're talking about functions of two variables, my inputs are going to be coming from a region, not an interval. And so I'm looking for a region. We need... So if z is equal to the square root of 1 minus x squared minus y squared, then the only thing really keeping us from having a defined function is the square root, right? So we need 1 minus x squared minus y squared to be greater than or equal to 0. And that's true if and only if x squared plus y squared is less than or equal to 1. Now, this might look familiar. This is the equation of a disk, right? X squared plus y squared equals 1 is a circle. X squared plus y squared less than or equal to 1 is all of the points inside the circle too. And so the region that is our domain is the unit disk. This is the domain D. And actually, I mean, you can see it visually, and maybe I'll use pink here. You can see it visually sort of hiding underneath this graph, right? It's all of the things in the plane that I'm plugging into the function and getting an output.